Alright, hello people, how y'all doing? Today we are going to go over numerical integration, improper integration, trapezoidal rule, Simpson's rule, midpoint rule, improper integration type 1. I think type 2 is next lecture. So let's get right into it. It does say here you're supposed to already know from Calc 1, your left point, your right point, your right endpoint, left endpoint, and your midpoint rule. So I'm not going to be really covering these. You guys, if you want to learn it, go back to your last semester lectures or find a lecture online on YouTube. So the first rule is trapezoidal rule. And what makes this a great rule comparing to your left or right hand rule is that, you see, if we were to use our right hand or left hand, we were using triangles like these. So you see, this one is more trapezoidal, which cuts your error room. So your error is less likely, your approximation is a little bit more accurate than midpoint because of this little slant right here. And so this is given equation. The only thing you need to know is this part. Alright, which is pretty simple. Your change in x is your bounds minusing each other divided by the number of ends you want to go. So we're going to go straight through this. And so your equation is not an equal. It's this little wavy equal, and this says it's an approximation. Because this doesn't give you an exact value. It gives you an approximation estimate, if I might say so. And so if I were to plug this into this equation, my bounds from 1 to 2, so I'll have, my bounds from 1 to 2, my f of x, which is e to the x squared dx, right? I zoom in a little bit. Approximated at t, n is 4, right? And so this equals, now you see the second one is an equal. And we have a delta x. What is my delta x? The change in x is your bounds, right? So we said the change in x is your b minus a over n. And so this is 2 minus 1 over 4, which equals 0.25, right? And so if I might rewrite this, this would be 0.25. Okay, so now going to the next step. This is going to be a bracket. And so right here, what I'm going to draw is a line representing this. And so straighten. All right. So this is my x at 0. And this is my x at n, which is 4. All right. And so we need 4 n's. So since we know the change is 0.25, and we know we're starting at 1, that means the next change is going to be 1.25. Right? And the next change is going to be 1 until we get to my x4, which is 2. Right? And so this is 1.5 and 1.75. And now this is what you plug into your equation. You see x0, x1, and don't forget your 2's. And so if I plug this in, I will have my function, which is my e to the x, and your x is going to be 1. And it says plus 2 times the function at 1.25 plus 2 times the function at 1.5 plus 2 times the function at 1.75. And you see, when I reach the end, and it says when I reach the end, and when I get to my xn, I don't have the 2 anymore. And so what this is, I'll just say 2, which is my f, forgotten f here, my f at 2. Horrible writing, I know. But that's about it. You plug all this in the calculator, and you will get your answer. And so it's nothing too hard when it comes to these approximations. They're pretty straightforward, I'd say. So we're going to go down to this next question. If they give you something application like this, and they tell you to approximate it, and what rule do they want us to use here? Trapezoid rule. And so this is the same thing. You want to take your bounds. And here, right, they don't give you your bounds, but you know this starts at 2, at x equal 2, at x equals, at x equals 2, and it ends at x equals 3.5. And so this is basically your line that I made earlier, which you have 2, 3.5, and we know we have 2.5, and we have 3 from here, right? And so I know my bounds go from 2 to 3.5, right, of my f of x, and this is approximated at t. My ends is what? 1, 2, 3, 4, right? But I believe 4 makes it 5, if I remember, yeah, see, this is 1, 2, 3. Oh, actually, no, it is 4. But I'm slowing, it's throwing me off with the numbers. We have 1, 2, 3, 4, yeah, 5. That's what I thought. And you see here it would be 1, 2, 3, 4, making n equal 3. Okay. And the steps your n is this is one step from 0 to 1, from 1 to 2, and from 2 to 3. 3 steps. And that's how you can think about it. And so what this equals is my function, and you see right here in the equation, my function at x0, which is 2. And this is plus 2, my function at 2.5, plus 2, my function at 3, plus not 2 because the last one doesn't take a2. And as you can see here, your last one doesn't have this 2 in front of it. And so that would be our approximation. Now, how do you approximate this? This part you would write the same. Right? Now, how do you approximate this? We do know my f at 2 is 60 plus my f at 2.5 is 75. So 2 times 75 plus 2 times 82 plus 2. Oh, well, we don't have a 2 for the last one. We just have 55. And you plug this into your calculator and you approximate. And that's really about it. Now, what is your change in t? I did forget one part right here. This is supposed to be my change in t or change in x. So I did forget that part. Let me get through it. There you go. And so here, what we're supposed to have is my change in x over 2, right? What is my change in x? And so like we said, you'll do your b from your a. So change in x equals b minus a divided by n. And our b is 3.5 minus 2 all over our n is 3. And so that will give us 0.5. And so my change here is 0.5. All right. Oops. My writing is not the best today. All right, now what's up with Simpson's rule? Simpson's rule is the same thing, but it only works on even powered n's. So if you have like above here, when we had 3 for n, Simpson's rule wouldn't work. And you see it does say it right here. It says, let me put this in red so it's more noticeable. That is horrible, man. Boom. Give me the square. Nice. There you go. N is even. So it only works when your n is even. You do the same thing, except now you have x to the 0, and then you have 4, then 2, then 4, then 2, and so on until you get to the last one where you don't put 4 or 2. And because it only works on even numbered, your 4 will always, you'll always start with 4, and since it's even numbered, you will end with 4. Okay? So I'm not going to really go through this. Simpson's rule is more accurate than your trapezoidal. Reason being is because this is curved. So you know our trapezoidal was something like this. And if I can draw some straight lines. So this was our trapezoidal, right? There you go. This was our trapezoidal. Your Simpson is actually, if I can make straight lines again. All right, and it's something like this, but it's bent like that. And so this minimizes your error until you have more approximation. You have more accurate approximation. And so your Simpson is more accurate, but it only works with even numbered ends. All right, approximate using Simpson's rule. I'm gonna leave this to you guys. The lecture is up with the notes, annotated. So it's just the same steps as earlier. The change in x is the same. Your 11 minus 5 divided by your 6 ends. You plug everything in. All right, this is just a bunch of gibberish. This is more of a multiple choice. There's not much to explain. You see it says midpoint and trapezoid are better and are similar to each other in terms of accuracy. But when it comes to right hand and left hand, your trapezoids and midpoint are more accurate. And it's just, you don't have to memorize any of these. So you don't have to worry about it. Maybe we'll ask for this. I don't think so. From midterm 1, they didn't ask. They didn't mention. I doubt you need to know this. So I'm not even going to cover it. it is on the lecture. These are like the shortcut equations. So yeah, you're probably like, oh well, why do they teach us this bullshit if there's a shortcut equation that looks like this? And it's like, yeah, I know, it sucks. Whatever, move on. This is your trapezoidal, right? And so if I go right here, trapezoidal, make a different color. Trapezoidal, midpoint, and where is your Simpson? Is this your Simpson? All right, and these are equations. Now you're probably gonna notice, oh, I have a k. How do I find my k? And it's actually pretty simple. You just want to get for your Simpsons, you just want to get your what do you call it? You want to get your fourth derivative, and you see it says it here. This 4. It says your fourth derivative. All right. And so if I want to approximate this using this equation instead of the long one, is it Simpson's rule? Yeah, it says Simpson's rule. And so let's plug it in. My approximation, which is my e to the s, is less than or equals to my k. My b is 0. Oh, sorry, my b is pi over 2. Minus my a, which is 0. To the power of 5. All divided by 180. My n is 4. Oops. All right, and this is to the power of 4 as well. Now, after you go through this, how can I find my k? And you're like, well, the thing is, this hasn't taken my function into consideration. Like, you see this whole equation, it doesn't matter what I have in here. It hasn't taken, just taken the bounds and the ends. So how does this actually approximate? And this is where your k value comes into place, and that's why you want to find your k, because it incorporates your function itself. And so k, this is how you find your k. That looks horrible. I'm gonna zoom in so I can make my writing looks pretty. And so your k is, how do you do it? Since we said up here k is your fourth function, so let's get fourth derivative. So let's get my fourth derivative. My initial function is cos x. Now my first derivative is, I believe, negative sign. And then I gotta derive this again. And this is just negative cos. And then one more time. This will give me a negative sign, right? These negatives will cancel out, giving us a positive. And so when I get it to the power of 4 of x equals, I get a positive, and then the derivative of this is just cos x. Right, and this is my fourth derivative. And if I plug it into the equation up here, what I get is the absolute of cos x is less than or equal to k. All right, and now, okay, well, I get this. How can I actually get my k value? And so you want to sub in your bounds. And you see my bounds right here are 0 and pi over 2. So what I'll do is the absolute of cos of 0 is less than or equal to k. And the absolute of cos of my pi over 2 is less than or equal to k. And so this will equal the absolute of 0 less than or equal to k. And this will give me the absolute of 1 less than or equal to k. And it's like, well, which one do I choose? You want to just choose the larger number. That's really how it is. The larger number is your k. But remember, if, for instance, this was a negative 2, don't think about it like, oh, this number, since it's positive, is bigger than this. It's the absolute. So when you apply the absolute, you'll get 1 less than or equal to k, and you'll get 2 less than or equal to k. And obviously, this is your bigger number. And so don't forget, take this back to 0. And so my bigger number is 1 less than or equal to k. And so I go up here and I'll sub in my 1. So e to the s absolute less than 1 pi over 2 minus 0 to the power of 5 all over 180 4 to the power of 4. And And that's about it. You plug this into your calculator and you'll get your approximation. Don't forget, when you get your approximation, you will do whatever this is equal like this. And this means approximated. All right. And that would give you your max possible error. All right. And so actually I made a mistake by saying this is the short version of this. That was a mistake on my end. This gives you the error, right? This gives you the maximum possible error, all right? And so keep that in mind. Okay, so moving on. So suppose we're approximating this using midpoint. If we want a maximum possible error of this, and this would be your absolute, right? What value of n should we use? And so you would do the same thing, except remember, for Simpson's rule, we're using f to the fourth derivative. But for midpoint rule, we only use the second derivative, right? So your k is less than or equal your second derivative, right? And you just do the same thing we did, except now you have to rearrange to solve for n, since you have your e midpoint, your error for midpoint. Okay. Okay, so heading straight into improper integrals, we're not going to do a lot of math here. We're going to do mostly the idea behind it. And so what is improper integrals? And just like they sound, they're integrals that you can't just integrate normally because they're not proper. And you see now, when you have something like this, we can integrate this. You will get here x to the power 3 over 3, and you take your bounds from 0 to 1, right? And then you'll get 1 to the power 3 over 3 minus 0 to the power 3 over 3. Okay, and you just integrate this normally, but what happens when one of the bounds is infinite? Right? This goes to infinity. And so even when you integrate and you get x to the power 3 over 3 from infinity to 0, you'll get infinity over 3 to 3 minus 0 to the power 3 over 3. It's like, well, what the hell does this mean? I can't use this. And so here it's asking a question: just because we integrate over an interval of infinite length, does this mean that the result is infinity? And so the answer is obviously no, because we never want to see infinity as an answer, because that doesn't mean shit. And so how can we integrate this so that we get an answer and not just infinity? And that's where we go into improper integrals type 1. And there are three possibilities, as you can see, is that you either have one infinity or you have both of them being infinity. All right. And I'm going to talk more about how we deal with this. For this part, the first thing you want to do is just split it. And so you'll say the integral from c, and we'll talk about more what c is, to infinity f of x dx plus the infinity from infinity to c. So you see I'm going from negative to c, and then from c to infinity, f of x dx. That looks horrible. By the way, I'm using my mouse to like teach these lectures. Like I'm not even writing with a pen. This is not my handwriting. This is literally me using a mouse. So cut me some slack. So if both converge, okay, so now moving, improper integrals are called convergent if the corresponding limit exists, and divergent if the limit does not exist. I haven't been through the limit, and so right now we're going to go through an example of what it means to converge, what it means to diverge, and also what I mean by the limit. And so now when I'm taking the integral of this, the first thing I want to do is obviously integrate. And so let's integrate before we take the bounds. And so what this becomes is your sine. And I'm trying to remember, I'm trying to remember if it's negative, but it's not. So sine x plus c, right? That's your integral. But since we have bounds, you got to apply your bounds, which is sine x from infinity to 0. And so this is just like we had the problem earlier. It's like, ayo, hold up. I can't take infinity as, my bound, because like I get an answer for infinity, and that doesn't mean anything. And so what can I say? I can take the limit to infinity. And so here's what I'll do. I'll say the limit from, you can say any letter you want. All right. So, but we're not taking the limit of x, right? We're taking the limit of the bound. And what letter do you want to make your bound? We can call it c. So as c goes to infinity of my sine x from now c to 0. All right, and this is any letter you want. And this equals to your integral from infinity to 0 cos x dx. All right, and now what you want to do is integrate, take the bound. And so what you'll do is you'll do limit as c goes to infinity, right, of my sine, but instead of x we put c now, okay, minus, now we take the second bound, which is sine at 0. Okay, and now what does this go to, right? And so this number right here, sine to 0, just goes to 0, right? Now what does this go? This goes to infinity. And so whenever it goes to infinity, because obviously sine will just on the thing, it will just go. And as x goes to infinity, what happened? As x goes to infinity, the function will keep going. And so if this goes to infinity, what we'll say is then this is d and e, and when you have a d and e, it diverges. And that's what diverging means. Diverges, right? Divergent. Okay, and so now we're gonna do a second example here, and let's integrate. And so it turns out, I'm trying to read this. What does it say? It turns out that from this one, p dx converges if p is more than 1, and diverges if p is less than or equal to 1. So let's go through it and see what this means. So I shall do it on the side here, and so I have the integral, my infinity, 1 of 1 over x3 dx. All right, I'm gonna zoom in and start working with this. And so let's see what we can do in this situation. The first thing, like we said, is integrate. And so now I'll have my integral of 1 over x to the power 3 dx. And this is the same thing as saying the integral of my x to the negative 3 dx. And that is the same thing as integrating. And you will get x to the negative 2 over negative 2. Right? And so if I were to rewrite this, what I'll get is 1 over, well, negative 1 over 2x squared. All right, and so simple enough. Now we got to take the bound, and since we have infinity, what I'll say is the integral of 1 over x cubed dx equals to my limit. So we're going to set the top bound, because if I turn this to bound, it'll be from infinity to 1, right? So now I'm going to set the infinity to the letter c, or well, not x, because our function is in terms of x. But you can set it to any letter. In the lecture, I believe they've been using w, so let's use w. Infinity. So as w goes to infinity, and this is going to be your w. All right, as w goes to infinity, of my negative 1 over 2x squared from w to 1. All right, and now you take the bound. And so let's do that. Let's apply our bound. And so we'll say limit as w goes to infinity of negative 1 over 2 infinity at power 2, right? And well, this wouldn't be infinity, my bad. This would be w. I just wrote infinity so we can visualize it. But you would write it like this. This is your correct syntax. And so plus my 1 over, and this would be, the reason this is plus is because when you integrate, this would be negative, but we already have a negative in our function, so it turns into a plus. So we have 2, my x is 1 to the power 2, right? And so this goes to 1 over 2, and what does this go? As my denominator goes to infinity, so if you do a number, 1 divided by 1, you get 1, right? 1 divided by 10, you get 0.1. And 1 divided by 100, you get 0.01. As you can see, as the denominator gets bigger, the number goes closer and closer and closer to 0. And so what we can say is, since this goes to infinity, this whole bottom goes to 0. As this goes to infinity, the whole thing goes to 0. And so what we'll have is, if I were to rewrite this, I get this goes to 0 plus my 1 over 2. Right? And this equals 1 over 2. And so therefore, this converges. And that's, to be honest, that's really how you do it. And so that's how you get whether your functions converges or diverges. And so if you see 1 infinity or negative infinity, so yeah, 1 infinity or negative infinity, you set the limits to your w and you solve it like this. If you have it both, you break into 2 parts and you will take 2 different limits. Okay, and that's about it. Hope you guys learned something today.